Okay, case 2 is going to be when the vertex of the function is known, but not the zeros. So let's quickly look at 7 and see these zeros are not exact points. So we cannot do case 1 for number 7. We're going to have to do case 2. We know the vertex. So again, we have a graph of a parabola and a table to show you 2 different ways. Okay, so in this case, we're going to use the vertex form. Y equals a times x minus h, the quantity squared, plus k, and another known point xy to write the equation. So again, we're going to end up solving for a and then rewriting in standard form. Okay, so let's zoom in on 7, and we have a quick guide of all the steps. Step 1 is to identify the vertex hk. So in this case, our vertex is at -3, 7. So anywhere in the equation, I'll be plugging in -3 for h and 7 for k. Then it says use another point xy. So for xy, let's just use something with a 0. That'll probably make it easier. 0, -2. But you can use any xy point. All right, so that's our step 1. Okay, step 2, let's write out the vertex form. And we'll substitute in each k xy. All right, so y is -2. X is 0. H was -3, so I'm going to make that +3, the quantity squared, plus 7. All right, so we're going to solve for a. Step 3, we'll solve for a. So -9 equals 9a, -1 equals a. All right. So let's just add up here to the list. A equals -1 of what we know. And then we are ready to plug into or substitute into the vertex form. All right, so y equals -1 times x plus 3, the quantity squared, plus 7, okay? So now we're on our last step, distribute, and we will have to square this binomial, of course, and write in standard form. Okay, so let's first square the binomial. That'll be x squared plus 6x plus 9, and then we'll bring the -1 in front down and the plus 7 down. Okay, so next I'm going to distribute -1 all the way through that trinomial. Bring down the plus 7, and once we combine those numbers, we will be done. Okay, y equals -x squared minus 6x minus 2. That is step 1 through 5. Okay, number 8, you might want to try it on your own if you're ready. If not, you can follow with me. I'm going to go through every step, but if you are ready to try on your own, go ahead and pause the video, and then you can fast forward a little bit to check with me. Okay, so let's go through everything again for number 8. We're going to identify the vertex, and then we are going to choose another point from the table. Okay, so with the vertex, though, we are going to have to use what we know about parabolas and their axis of symmetry. So this is the vertex because I see on either side the y values are -2 when you go one step away okay? And then 7 when you go 2 steps away from the vertex. So you have to use what you know about parabolas to be able to identify this from a table. So HK is going to be 2, -5. And then again, if you can, I would use the XY point with a 0. It's just a little easier in an equation if you can have one of your variables equal to 0. Okay? But any point will work. All right, so we did step 1. I'll zoom out so we can see the steps. Then we're going to substitute HKXY into our vertex form. All right, so y, let's substitute everything at first. So y is 7, or everything at one time. Again, x is 0. Then minus h would be -2, the quantity squared. Then k is going to be a -5, so we'll -5. Okay, so 7 equals a times 4 minus 5. So that will give me 12 equals 4a, and 3 equals a. So we solved all the way for a, and let's add that to what we know. All right, so going back to our equation here, y equals 3 times x minus 2, the quantity squared, minus 5. Okay, that's where we're at. So then we just need to do our last step, which is write in standard form. So I'll zoom back in for that. Okay, so make sure if you did this on your own, you are checking what you did with me. So we'll square that binomial, and we're at y equals 3 times x squared minus 4x plus 4 minus 5. Let's distribute the 3. Bring down minus 5. Okay, and we are done here. So y equals 3x squared minus 12x plus 7. All right, and that is it for case 2. Now let's look at writing exponential equations. Standard form again is y equals a times b to the x. So given an exponential pattern with a common ratio, we can write the equation as y equals ab to the x, where a is the initial value, or y-intercept, and b is the common ratio. So looking at number 9, a graph, and 10, a table, we are going to try to identify A and B, and then we will have our equation in standard form. Okay? So let's start with 9. We have a graph. We can identify A pretty easily because it is the y-intercept of 2. Okay? The coordinate is 0, 2. But the y-intercept of 2 is going to give us the value of A. Okay? So then to find the common ratio, it's a little more difficult to just look. So let's look at these coordinate points. We have 0, 2, and so we can identify some other coordinate points and see the ratio easier here, okay? So each box on y is 2, all right? And then each box on x is 1. Okay, so this coordinate point will be 1, 6. And then our other coordinate point here will be 2, 18. And our x is increasing by 1. So we have a constant value for x. The y is multiply by 3. That works, okay? So the common ratio is 3. That means b equals 3. So we can go right to standard form and substitute 2 for a, 3 for b. So this is y equals 2 times 3 to the x. Okay, so let's do the same thing for 10. Okay, let's do the same thing for 10. So we have an xy chart here, and the x-intercept, or excuse me, the y-intercept, we can just look because the x is 0. So a will be 48. Okay, and now let's find the common ratio. I'm going to move that down. So each time, 48 divided by 2 is going to be 24. Okay, so this is an exponential decay, but we are going to have to identify what is multiplied each time. So in this case, you would multiply by 1/2 to get from one step to the next. That's your common ratio. Multiplying by 1/2 is the same as dividing by 2. Okay, and then 6 times 1/2 is 3. Okay, so b is 1/2. All right, so standard form will give us 48 times 1/2 x. 1/2 to the x power is what I meant there. Okay, so that is standard form for number 10.